Our first simulation could move a box across a conveyor. At first glance, that seems like a progress, but from an engineering perspective, the machine still has no idea where the box actually is. Imagine I stop the simulation here. Can the program answer whether the box has reached the sensor? Can it tell if it has passed the diverter? Right now, it can't. It only knows one thing: keep moving. Real conveyor systems aren't just empty belts. They contain important physical locations. Engineers don't think in pixels. They think in meaningful positions such as entry points, sensors, diverters, and exits. Instead of immediately adding sensors, we first ask a more fundamental question. How does a machine describe its own world? Before a machine can react, it needs landmarks. Notice that nothing new happens yet. The box still moves exactly as before. The only difference is that the conveyor now has a defined geography. We've taught the machine where important locations exist. These values don't control the machine. They simply describe it. Think of them as a map. We've separated the moving object from the fixed world it moves through. Version 1 answers a simple question. How do we make something move? Version 2 answers a more important one. Where is it? Every industrial automation system builds on this foundation. Now that our machine understands its geography, a new engineering problem naturally appears. How does the program know the box has crossed one of these locations? That's the problem we'll solve in the next milestone.